Okay, hello guys, once again. As I said, today we are going to talk about how to apply domain-driven design on examples of clean architecture and how to use TDD, with example on Kotlin. The purpose of this presentation is to show how to work with the customer requirements and basically how to transform them into the diagrams and the code using the test-driven approach. Well, a few words about me. I'm a senior software engineer at Fort Remit. I have been working in this company almost 3 years. I have around 20 years experience in designing and developing software. I'm actually a fan of the clean architecture when sourcing and DDD. I like to experiment with approaches. Actually, I'm a father of 2 boys and I play hexagonal architecture. Sorry, I mean hexagonal guitar. I mean jazz guitar, sorry. You know, I just couldn't help but take the chance to show off my new guitar, guys. Sorry for this. Agenda. A little theory at the beginning, yeah. We will consider DDD definitions and goals. Clean architecture and varieties of layered architecture patterns. Then we will show you how to apply DDD and hexagonal architecture on the examples of to-do list application, defining strategic design, tactical design, application design. Yeah. Then we are going to write a bit of code on Kotlin using TDD, and at the end we will summarize what has been done. So let's go. Okay, what is DDD? Domain-driven design is an approach to software development that centers the development of programming a domain model that has a rich understanding of the processes and rules of a domain. Yeah? The concept is far from new, to be honest, because first is appeared in the famous Blue Book of Eric Evans in 2003. He described the approach to the catalog of patterns, and since then, a community of practitioners have further developed his idea, spawning various other books and training courses. For example, there is a great red book called Implementation Domain-Driven Design, with a lot of examples written in Java language. And by the way, I highly recommend to have at hand both of these books. They're great. Okay, DDD goals. Domain-driven design is predicated on the following goals. There are 3 main goals, and first is strategic design, also called strategic modeling. It's a pillar of DDD whose main goal is to define bounded context, ubiquitous language, and context maps along with the entire project team. Second is tactical design, also called tactical modeling. This is a part of DDD related to building blocks, which are aggregates, entities, value objects, events, modules, etc. And we will go through all of them later. And architecture design, it mostly refers to the style of architecture and other technical aspects. So like defining applicability of different architecture styles. It could be like onion, hexagonal architecture to apply our DDD, okay? Okay, and what is actually clean architecture? The concept of clear architecture for the first time is appeared in the book Clean Architecture of Uncle Bob, that originally published in 2017. Basically, he does not give a concrete definition of what clear architecture means, but he is referring to definition of other architecture which are built on the layers. So we can create and try to create definition by ourselves and to say clean architecture is a software design philosophy that separates the element of the design into layers, giving every layer all responsibility. And let's consider several of them. Hexagonal alternative name is port and adapters. We have entity control boundary also, and onion. This architecture are very somewhat in their details, but in fact they are very similar. They all have the same objective, yeah, which is separation of concerns. They all achieve this separation by dividing the software into layers, where each has at least one layer for business rules and another for the communication and infrastructure. And now I want to go to the entity control boundary. The entity control boundary pattern is actually some way of this variation of model view controller pattern, very popular. Depicted entity here, defining objects representing system data, often from the domain model. Boundaries are objects that interface with system actors, like with the users or external system. By the way, Windows screens menus are example of boundaries that interface with the user. And control, actually objects that mediate between the boundaries and entities. Okay, onion architecture was introduced by Jeffrey Palermo to provide a better way to build application in perspective to testability, maintainability, and dependability. This pattern implies to split the software in four layers, four basic layers. It's a domain layer, repository layer, service layer, UI layer. So that it develops a loosely coupled application. As outer layer of the application always communicate with the inner layer only via interfaces. It actually means that domain layer does not know about repository, service, and infrastructure layer. The same as like repository layer doesn't know about the service layer. Okay, let's take a look on the hexagonal architecture. And in my opinion, to be honest, it's very, very similar to the onion. It is also based on the inversion of control principles. And just to remind, this is the principle says that high-level modules should not depend on the low-level modules. Both of them should depend on abstractions. The author of this pattern did one just small things. Yeah, they're clearly focusing an attention of the concept of port, meaning interface, and adapter, meaning implementation. Like port and adapter, it's actually its alternative name of the hexagonal architecture. This name is easy to remember, like just port and adapter. Okay, let's consider some basic principles. Again, core domain logic has to be fully independent, like isolated of transport mechanism. Yeah, it could be REST, Kafka, gRPC, etc. Transport protocols, Avro, Protobuf, JSON, XML. Databases, storages, yes, it could be SQL, NoSQL, doesn't matter, cloud providers, Amazon, Microsoft, Google, libraries, frameworks. It's basically our domain logic does not care of this sort of things at all. Well, look at this picture, please. This is a paper making factory. And what do you think? Is printing house should be interested in by what method the tree was processed? Or for example, the paper conveyor doesn't really care what the transport was used to deliver the raw material. And basically functional modules of this conveyor were allocated into layers, yeah? And each with its own specific responsibility. Like just divide and conquer, yeah? All right, okay, and now I want you to imagine that we are engineers of some software house Yeah, we got the requirement from the customer to run and develop crazy, let's say, crazy startup that calls to-do list. And of course, like any busy businessman, he sent us just one mock-up, like, and few points to be done. Like user can create new to-do, mark as a done, edit a title, delete to-do, and share to-do with a friend. So it looks simple, right? So maybe let's just code it. But stop. What? Like share to-do with a friend? Where is it in a mockup? What friends? Where to find these friends? I already wrote a bunch of the code, and only now I drew attention to this detail. You know, looks like our customer also did not figure out like himself what he wants. And maybe it's not so simple. Classic situation, right? It's a very common practice when we like got superficial requirements, and once we read them, we say, come on, it's easy, 1 week and this will be on production. But then we understand this is not so easy as it seems to be us, right? Before, and later it turns out something like we see on the picture. I don't know, do you recognize yourself on this situation? Because I'm yes. Well, so let's better to have a plan. I propose together with our customer, work out our strategic design, just deeply focusing every use case of our system, transforming requirements into diagram, and also find out which devices our application will run on. Then let's make tactical design, building our domain model, our blocks, and later we will develop our architecture layers. And finally, we can write the code, of course, using test-driven development approach. Okay, and wow, just look on it. Seems like already after the second meeting with the customer, we found out that even more new use cases. Yeah. Now it turned out that he forgot to mention the user should be also has ability to register and log in, and also user has to manage friends, adding and deleting them. Yeah, it's really interesting what else he is up to. And it seems like now we definitely need to go one by one through the every use case. And I propose to start with create new to do. And look, it turns out that we cannot create to do when the given due date expired or title is too long. Well, but you say, but maybe let's leave it for front end only. But no, because our customer wants to have the validation on two sides. Yeah, because actually he afraid that the to-do list application can be hacked by hackers. Like server validation, that's it. Yeah, it's funny. Okay, but what about update title? Interesting. User cannot update the title when he marked to do as a done. Really? Why? Because done is done. The past cannot be changed. And this is the answer I received from our domain expert. Of course, as you wish. So I think we definitely need to go through the every use case, examining each one very carefully. All right, so let's assume we gathered all information about use cases, and now we need to define our component model. The decision was made that our application will work with two clients supporting different protocols. The mobile client will work on the gRPC, because our mobile developers admit only gRPC at this moment, okay? And the website expect basically a RESTful, just classic RESTful communication. We also need to publish the event into the sum buffer. For example, it could be like Kafka topic. We have not decided yet, okay, to notify the user about the shared to-dos. So, and seems like the hexagonal architecture is more and more getting applicable in our case. Nice. What lesson can we learn from this, okay? First of all, do not rush to write code, okay? So draw use case diagram, show them to the customer, deeply discuss every use case. Try to predict the requirements. It will force you to ask the right questions. Find out the infrastructure environment, like upstreams, downstream systems, expected traffic volume, security requirements, etc. Cool. Okay, we figure out with our strategic design, we gathered all needed requirements, and we are ready to build the domain model finally. Actually, in the world of DDD, there are two types of models: anemic models and rich models. Anemic model, this is a class that contains a set of fields exposing only getter and setter methods only. But the rich model, this is a class that contains a set of fields exposing behavioral methods that are strongly correlates with the business use cases. For example, in our case, we have create to do, we have update to do methods, we have share, etc. Those all methods expose behavior. We will consider more detailed when we will be implementing them, but yes, basically they are expose the behavior. So our to-do aggregate here is actually a good example of rich model. Also, the given model is very important. The given model should be fully technology agnostic and purely concentrated on the business rules. Yeah, based on the business language, we also introduce some, let's say, value objects. Yeah, for example, look at the title. Yeah, this title has method that validates the given length of the text. It's called is too long, returning Boolean. Actually, all those terms, value object, entity, aggregate root, those all terms were introduced by Evans in his blue book. And I would like you to pay attention on the definition one by one. Aggregate, this is a cluster of domain object that can be treated as a single unit. Yeah. Basically, it's called aggregate because it composites other objects like here, like a user, title, due date, etc. Entity, and please do not confuse with the entity from Hibernate. It's actually object that has identity, has ID. Each entity is uniquely identified by the ID field rather than by the state of the attributes. And value object is an immutable type that is distinguishable only by the state of all its properties. Actually, that's unlike an entity which has a dedicated field ID. Yeah, for example, UUID that identifies this object. Okay, and now what is actually event here? Event, it is a mutable object that is created and returned by the rich model in order to provide a response to a specific operation. Okay, with simple words, event, it's an operational result. And please do not confuse with the concept event from event-driven programming, because our event, it's a purely domain object and returns synchronously and has no no command with event-driven programming here. As you can see, we divided successful events and rejection into two different groups because we in favor to do not throw business exception, and instead we return specific rejection event. And actually, I want to highlight we are talking only about business exception, not technical. And well, I think this is definitely another topic for discussion. But if you want, you can just surf the internet why it's better to build like business logic on exception, etc. Okay, fly further. Great. So we built the domain model. Oh, wait, sorry. Okay, we build the domain model. Super. And so now let's define the layers that we were talking about at the very beginning of the presentation, remember? Like clear architecture, layers, stuff like this. Do you remember our hexagon? Application layer, domain layer, infrastructure. Okay, let's now maybe refresh our memories. Application layer, it's basically an API of our interface. This layer handles the request from the client and delegates it to domain logic, transforming and return back the response back. Domain layer, it's basically our favorite, right? This is a core of our service. It contains the business logic accessing infrastructure through the ports, so interface. An infrastructure layer contains the adapters, those classes that implements our port. And I propose to look on it more detail. The flow starts from the left side. When the client mobile application, it could be a web client, triggers the domain, triggers the application layer with a request. The task of the controller is to handle the HTTP request and do some shallow request validation. And I want to highlight that shallow validation. It means just check the data is correct. And that's it. For example, to-do title is not empty, or like due date has good date format, etc. Then controller has to invoke the concrete method of the use case class, converting the HTTP data into domain objects, like our DTOs, yeah? Saving so the domain layer to know about the DTOs from the application layer. As I was saying before, yeah, so domain layer doesn't know at all about any DTOs from your mobile application or web client, from, you know. Okay. By the way, the group of use case classes, we can safely name a domain orchestrator because it knows which port to use to receive the data and which port to use to save the data. It knows what's the method to invoke on aggregate and what to do with it, with the result, sorry, with this event actually. And later we will back to the use case classes and consider their flow more detailed. And as I mentioned previously, the use case class orchestrator, using the dependency inversion principle, know only about ports, so about the interfaces. But the real implementation of those ports are placed in the infrastructure package. And here, of course, some libraries and frameworks come into play. Yeah. Okay. By the way, to do aggregate, we already designed in scope of tactical design, remember? And as I promised, we come back to the use case classes. Let's jump inside and see what's going on inside. Okay. As an example, I propose to consider one of the specific use case classes. And so what actually does contain this create to do use case? First of all, we see the create method that accepts as a parameters domain objects such as title, due date, and it returns the domain event that we got from the to-do aggregate. It also has this data storage interface and event publisher. And I want to highlight that it's still domain layer. That's why only domain structure are allowed here. And maybe some of you will say, come on, you always will have only one adapter in real project. And you know what? Actually, I'm ready to refute this statement, because during working at WordRemit, actually we have changed adapters twice. The first case was when we were integrating with the transactional outbox table, saving the Kafka messages inside database instead of publishing directly to the topic. And the second time, it was during the migration of gRPC. And by the way, there is also a probability that we will be using other type of databases. Okay, now I propose to look into the create to do use case flow. Okay, and what we see here, we see that accepting the web request, controller maps to our DTO to domain objects and delegates to the scope to use case class. Use case class, in turn, creates an aggregate and delegates the call to it. And if the returned event is not a rejection type, it is saving into our storage and then publishing. Next, this event is returning also to the controller, and controller maps to DTO, gives it back to the client in the shape actually of HTTP response. Yeah, fantastic. We actually finished our architecture design, and finally we can go to the implementation part. Cool. Okay, and as it was stated in the title of my presentation, we will be doing it through the test. And the good question would be where to start. And of course, we have to start from our core, from the domain, yeah, rising the level like higher and higher. And by the way, as we finished the implementation of our domain model, we can parallelize the work between other people. It's very also important and nice. It means actually that we can independently start implementation of other layers. For example, one person can start work on REST controller from application, yeah. Another one start implementation of Kafka publisher in infrastructure layer. And by the way, it is extremely increases development speed. Okay. So let's leave behind this stuff like preparation and the project on Kotlin, and let's go straight to the point. First of all, hope you still remember this block schemas, right? And now I propose to write just empty. Sorry, I propose to write just empty test scenarios, and first based on every checked from our business requirements. For example, should create to do successfully, should reject to do creation when due date is expired, should reject to do creation when the title is too long. And I think it would be enough. Then we have to run this, of course, test and see that all of them failed. Yeah, we see that all of them failed. Nice. Now we have to just write tests, creation new structures on the fly. Yeah, it is very important because it's very important to concentrate on what test is going to do, like not being too distracted by the implementation of the structures and the logic itself. Just build minimal structures and create only what will be used in this test. Yes, and we see some structures like title, user, due date not created yet. Excuse me. Okay. So we finished the test. By the way, we divide it into the section given when then. In the given section, we create our input parameters. In the when section, we call the aggregate methods passing input parameters. And in then, we check in the output event has type to do created, and we are checking the rest of the fields here as well. Well, so now let's take a look on our let's say first version of the aggregate. As you see, we have no validation at all. Yeah, we simply accept parameters, apply new state, and return successful in event because we wanted to make our test green, and actually it is green. During the test writing, we have created also other domain structures, like user, like a due date, title, created, add, as you see, to do ID and our events. We added also useful methods for generation UIDs inside the value objects. It's also very useful. Okay, so, and right now let's go to the next scenario. The second test is very similar to the previous one. We actually can just copy paste the previous one to this. But now we need to create a to-do with a past due date, yeah, with some expired due date. And actually we here use like minus 60 seconds for this expired due date. And make sure the reject event is returned, which is not created, of course. And by the way, what I really like in testing domain-rich models that we do not need any mocks at all. It is really cool in my opinion. No mocks, yeah, in this domain logic. Okay, we created a new rejection event, right? Yeah, we also put some message. Message also important because we need to know the reason of a rejection. And we need to run this test. Yeah, we need to run because we need to be sure that it's failed. And indeed it's failed because we expect what we expect to do date expired rejection event, and we got to do created. Yeah, it's okay. Now let's modify our to do aggregate. Adding actually needed check at the very beginning. Creating of course new method on the fly. Yeah, I put just is expired on due date. We added method is expired right on the due date value object. And by the way, I love value object for it. Yeah, besides it encapsulates the type inside. It also allows to make them like richer from the business perspective. Yeah, it's very clean and useful. And actually, value objects can even have its own unit test, only when the logic, of course, complicated. Okay, we are adding the last test for the creation to do use case. simulating a very long title. Yeah, we put very long title here, and yeah, we add this check to the aggregate. Yeah, of course, we have to put some reason. So cannot create to do with a long title. Yeah, it also would be good to put maybe some IDs. Okay, so we need to run all tests, of course, and we see that all of them green. Good job. And important, yeah. What else we need to? What else needs to be done? First of all, unit test and implementation for all other scenarios of to-do aggregate, because we consider it only one to-do creation. Then we have to we have unit test. We need to implement the unit test and implementation for our orchestration classes, such as create to-do use case, update title use case, etc. And here, of course, we need to mocks the ports, like data storage, event publisher, etc. Unit test for and implementation for the application layer, like REST controller, gRPC service. Here we need to mocks, by the way, orchestration classes. So we need to mocks use cases here, because we will be, you know, so we actually mock everything what we are not testing right now. Or, of course, unit test for an implementation for the infrastructure adapter, our adapters layer, like Kafka, event publisher, GPA, data storage, mocking all dependencies. And what is also very important, it is important to have an integration test to check that our build blocks are correctly integrated and connected with each other. Yes, we created like a unit test, we did a lot, but it's very important to see that they communicate with each other well. And of course, UI test. It is also important to check the front end together with back end at the very end. Sorry. Yeah, so disclaimer. There is also one important thing I want to say. As actually Martin Fowler also once said that the DDD approach is particularly suited to the complex domains, where a lot of often messy logic needs to be organized. Because so I actually think that for using so using a pattern for the sake of the pattern, it's not a good idea, right? For example, yeah. For example, if you have just simple CRUD logic, you don't need actually to apply DDD here, and most likely you don't need at all your domain layer with your all rich models. You will not have rich models. You will have basically anemic models. It will. I actually just do not complicate. Yeah, just keep it simple here. Okay, so sorry. Let's summarize what we have managed to do today. First of all, we worked out our strategic design with our customer. Yeah, we completed tactical design, building our domain model. What we did, we applied the hexagonal architecture to do service, and we implemented our solution using the test-driven design, test-driven development. Okay, so today I told you an approach that I personally used for several years. Okay, maybe not several, last year for sure. I also know that this is a very complex topic, and many nuances have not been addressed yet. Therefore, if you want to ask me something, you can drop me email. Yeah, I would be very glad if someone does it. Yeah. And by the way, WordDream is actively looking the engineers. Contact me. You can I can provide you with the detail, or you just can submit your CV directly to this website. I put this link here. And what? I thank you everyone for your attention. Ask me question if we still have time. If not, so you can send me email. And let's back to the studio.